force on the rod, then acceleration of the wire, tension at a certain point, longitudinal stress, longitudinal strain, and change in length of the wire. So firstly, net force is because forces are opposite, so net force will be F. Then acceleration is net force by mass. We can calculate acceleration. Then we need to find tension. So for finding tension, we need to make the free body diagram of this. And after final calculations, we get tension as this much. Then finally, after that, we need to find stress at that point. So stress is force by area, so that will be stress. Then we need to find the strain. Strain is found to be this much. Then consider a point at a distance x and a thickness of dx. So for this elemental wire of length dx, let us calculate the change in length. Delta L is this. So delta L comes out to be f dx upon a y. So if we calculate the elemental change in length, so that elemental change in length is given by this much. Substituting tension, we get this much. Then integrating the expression, finally we get, after all the calculations, delta L comes out to be 3FL by twice of AY. So now to escape from integration, we can use a simple trick. We know that delta L is F equivalent L into AY. So you just take F equivalent as F1 plus F2 by 2. So just use this and you get the same result, just to escape the integration, but it is how it works. Next is a question based on applications of elasticity. So the first application is I-shaped girders. You must have seen in railway track I-shaped girders are used. So they just increases the area. So because of increase in area, stress decreases. Then we need to find a maximum height of a mountain. So suppose there is a mountain of h height, we can assume that to be considered to be approximately a cylinder of height h. We just calculate stress at the base. So for safety, that stress should be less than the breaking stress. And using that, we get the highest height as 10 kilometer, which is practically true, as the highest mountain in the world is perhaps Mount Everest with a height of 8848 meters, which is obviously less than 10 kilometer. Then we have the concept of buckling of beam. So buckling of beam is concerned with when a beam is put over a structure, then with due time, due to gravity, it gets bent. So if it is a straight like this, then after some time it will get bent like this. So if the separation between the centers is del, so that is called buckling. And on the basis of